We will discuss about the graphical method. And already in your earlier classes, you learnt about the factorization method, and I just mentioned in the previous class. And now, using the perfect square method, we have to generate a formula to find the roots of the quadratic equation, right? See, basically, perfect square method is the standard one. Using that perfect square method, we need to find the roots for the quadratic equation. Have a look at this. I already told you, quadratic expression is an algebraic expression with second degree. A second degree algebraic expression in one variable is usually termed as a quadratic equation, and the general form of the quadratic equation is, as I mentioned in the previous class, ax square plus bx plus c is equals to 0 is the general form of the quadratic equation. And in this equation, this a can't be 0. Just look at this. If this a is equals to 0, what will happen? If this a is equals to 0, then automatically this term will vanish. Then you left with this bx plus c. That means then at that case this quadratic expression will become like a linear equation. Is it right? Actually, ax square plus bx plus c is equals to 0 is the general form of the quadratic equation in which x is an arbitrary variable. That in the sense we have an independent chance to take any real value in the place of x, right? And a, b, c are constants, any real or complex constants. See, this is mentioned as the general form of the quadratic equation only if this a is not 0. Because if a is 0, then there is no second degree term in this equation. Then why we call it as quadratic? Then it becomes like linear, right? So that's why to mention it as surely as a quadratic, you need to make sure that whether a not equals to 0 or not. So in generally, we will consider this ax square plus bx plus c is equals to 0 for a not equals to 0 as a general form for the quadratic equation, and that's it. And now my task is finding the roots for this general quadratic equation, right? See, finding roots. So we have different methods, and basically we will utilize either factorization method or the perfect square method. Perfect square method is a standard one which is helpful to find the roots for any type of the quadratic equation, whereas factorization method may fail in some cases, right? And now look at this. Try to find the roots for this quadratic equation using perfect square method. As we discussed in the last class, to use perfect square method, initially we need to search for a perfect square term in the given expression. Look at this. Is there any perfect square term or not? If you look at this, ax square plus bx plus c is equals to 0. No perfect square is there here because we don't know about the value of a. So to get at least one perfect square in this equation, I am going to divide the whole equation with a, right? So in the next step, what I will write it is ax square plus bx plus c divided by a is equals to 0 divided by a. Is there anything wrong? Nothing wrong. Why? Because we divided with a and that a is a non-zero number. See, we have an independent chance to divide both sides of an equation with a non-zero number, right? So now, if you split it, how it becomes? Ax square by a is x square plus b by a x plus c by a is equals to 0. Ax square by a is x square, this is b by ax, and this is c by a is equals to 0. Now, just have a look at this. We need to utilize perfect square method. That in the sense, as we mentioned in the previous class, we need to make either some p plus q whole square or some p minus q whole square format. So keeping this p minus q whole square or p plus q whole square in my mind, I will rewrite it like this. I think you are all aware because we did a problem involved with numbers in the last class. See, this is x square. Look at this. This is b by ax, is it right? And I will rewrite it like this: 2 into x into b by 2a plus c by a is equals to 0. Is there anything wrong? Look at this. Nothing is wrong. Just I am rewriting this b by a x as 2 into x into b by 2a. If you look at this, 2 and 2 will get cancelled, then automatically these two things are equal. And this x square and c by a as it is I wrote here. And now see, since my idea is to convert this into a perfect square form. A perfect square form needs like p plus q whole square, it needs p square plus 2pq plus q square. Just look at this and then again look here. See, like x square we have here p square, and like the 2pq we have here 2xb by 2a. Then by comparing first two terms of this equation with this perfect square, it is very clear that this b by 2a is nothing but the q there. So with that idea, see again look here. See, with that idea what I am going to do is x square plus 2 into x into b by 2a plus, and this b by 2a can be written as, see, that in the sense I will add 1 b by 2a whole square and I will subtract 1 b by 2a whole square plus c by a is equals to 0. Just look this, I am just adding 1 b by 2a whole square and I am subtracting 1 b by 2a whole square just to make a perfect square here, right? See, so this is ax square plus bx plus c is equals to 0. Divide everything with 1, and to make a perfect square, this is x square and the second term is just 2xb by 2a, and if you treat this b by 2a as some q, you need to add q square and subtract q square to make a perfect square. For that, I am just adding the square of this b by 2a and subtracting again. Now if you look at this, the first three terms here, what are the first three terms? X square 2xb by 2a plus b by 2a whole square, and the next two terms. Separately you need to simplify, right? So here as I told you, this a is not equals to 0. For the space concern, I am going to erase this. Look at this. Yeah. Right. So now what I have to do is, look at these three terms. These three terms are of the format some p plus q whole square. Here that p is x and that q is b by 2a. So I can rewrite it like this. How can I rewrite? I will rewrite it like this: x plus b by 2a whole square. Is it right? The three terms will become like x plus b by 2a whole square. If you wish, try to check it. X square we have here, 2xb by 2a is the second term here, and b by 2a whole square is the third term. So these three terms are nothing but a perfect square. Absolutely right. And then look at these two terms, right? Minus b square by 4a square. If you apply the square for these two, it becomes like this: minus b square by 4a square, and plus what we have here, c by a is equals to 0. And from there we need to simplify. So you just send these two terms that side as a part of simplification. For my convenience, I am sending that side. Or otherwise, what I do, I will do actually, I will use some p square minus q square again. So look at this, what will happen? This is x plus b by 2a whole square. From these two terms, if you pick out minus, and again, if you take 4a square as LCM, pay your attention here, then surely it is easy for you. See, 4a square is an LCM. This is b square. Since I pick out minus as a common one, you need to write again minus here, because minus into minus will become plus there. And then here the denominator is a. So to make it as 4a square, I need to multiply with 4a. Then I need to multiply with c also with 4a. Minus 4ac is equals to 0. Is it right? Right, exactly. And now this implies x plus b by 2a whole square minus, I just rewrite it like this. How I can rewrite? I will rewrite it like this: square root of b square minus 4ac, square root of b square minus 4ac divided by 2a whole square is equals to 0. Is it clear? Exactly. See, square root and square will get cancelled, as well as this 2a whole square is nothing but 4a square, right? See, I am trying to find the roots for the general form. See, if you find the roots for the general form, that is the generalization for the roots, and you can use those roots as a formula to find the roots for different types of quadratic equations. And after this, how to move? Just look at this. Now this is of the format something square minus something square. P square minus q square. So that p square minus q square is nothing but p plus q into p minus q. For the space concern and just for our understanding, I am just replacing, I am indicating, look this b square minus 4ac, I just utilize it some d in the place of that b square minus 4ac, just for my convenience, right? So in the next step, look at this, some p square minus q square or a square minus b square or alpha square minus beta square is nothing but alpha plus beta into alpha minus beta. So x plus b by 2a plus this bracket. What is that bracket? Square root of d by 2a into x plus b by 2a minus square root of d divided by 2a is equals to 0. And now see, I am just concluding here with my explanation, right? Look this, the product of these two terms is 0. When the product will become 0, as we discussed in the previous class, product of two terms is 0 if either of those two is 0. That means either this is 0 or that is 0. If this is 0, then what is the value of x? If this is 0, your value of x is equals to minus b, and then this it also moves that side, the denominator is 2a only, no? Minus b minus root d by 2a. Or if this is 0, then you send b minus b, and that minus root d will become plus root d. So minus b plus root d divided by 2a. At the end, see, the roots of this general form are nothing but minus b minus root d by 2a or minus b plus root d by 2a. Our work is here completely about roots for ax square plus bx plus c is equals to 0. See, in the last session I mentioned you about the basic definition of the root of an equation. Root of an equation is nothing but value of x such that it need to satisfy this particular equation. That means we need to find the values of x if that equation is 0. So to find that, we have a perfect square method as a tool. So if we move with the perfect square method, to make it a perfect square, first I divided both sides with a. Since a is non-zero, it is possible that division, right? And then I have that x square plus b by a x plus c by a is equals to 0. Clear? And now just I am rewriting this middle term b by a x as 2 into x into b by 2a. I won't change the first term, I won't change the third term again. And now this second term is like this. And if you compare this second term with the perfect square form of p plus q whole square, we need q square. That's why I added the square of this b by 2a as b by 2a whole square, and again I subtracted. And now look at the first three terms as one group and the next two terms as another group. And in the first group, these three terms combinedly will give us x plus b by 2a whole square. And the second group, we have two terms. Those two terms are like this. And then from these two terms, just pick out minus and then took LCM as 4a square. And in the next step, I have a chance to rewrite in the form of a square the second term only. So root of b square minus 4ac by 2a whole square. Both these two are same. But to move further, I am just taking this b square minus 4ac as some d. If it is d, I have again a chance to utilize some x plus y into x minus y, x square minus y square formula. With that, see, sum of these two into first one minus second one. If the product is 0, if either of those two is 0, if this is 0, x is this particular value, or if that is 0, your x is this particular value. Have a look at this. At the end, with the general form, we have these two as the roots, and I will continue from there. Have a look and go for a screenshot. With this complete process of perfect square method, at the end, from this equation, I have two values for x. And those values are x is equals to minus b minus root d divided by 2a or minus b plus root d divided by 2a. For since I replaced that b square minus 4ac with d, right? So for d is equals to b square minus 4ac, right? So After this total work, at the end, I have, see, x is equals to minus b minus root d by 2a and x is equals to minus b plus root d by 2a, whereas that b is equals to b square minus 4ac. Now if you replace this b square minus 4ac in the place of d, we have two roots. See, if you look those two roots, they are symmetrical with just a minus sign here, right? So for one value you need to take plus sign and for the other value you need to take minus sign. So if you combine those two, at the end I will mention the roots of this general quadratic equation as minus b plus or minus. Plus or minus in the sense, either you may take plus or you may take minus, but both you need to take because there are two possibilities for here. Minus b plus or minus square root of this d is b square minus 4ac, right? So replace d with b square minus 4ac divided by 2a. So if you have a quadratic equation of this format, and then just try to identify the constant values a, b, c. And after identifying those constant values, if you replace them in this minus b plus or minus root of b square minus 4ac, it gives us two values and those two values are known as the roots of the quadratic equation. And in basically we call those roots as alpha and beta, and that's a further task. Just have a look at this. For suppose we did a problem yesterday related to the finding roots for x square minus 5x plus 6 is equals to 0. We find the roots for this equation using what? Using factorization method as well as using perfect square method too. And now try to find the roots for this using our what? Yeah, formula method, right? Using these formulas we have to find. How to find? First of all, look at this. Ax square plus bx plus c is equals to 0 is the general form, and the given equation is x square minus 5x plus 6 is equals to 0. You just try to compare this given equation with the general form. If you compare like that, x square coefficient is a here and here x square coefficient is 1. So a is equals to 1. And then here x coefficient is b and here x coefficient is minus 5. So you need to take b is equals to minus 5. And then here c constant and here c is 6, right? So you need to utilize this formula to find the roots. Now for the roots we need to utilize this formula. How to find the roots? Yeah, the roots is minus b. So minus b means this b is minus 5, minus b means 5, plus or minus square root of, I can write directly, b square is the square for this minus 5 and the square for this minus 5 is clearly 25, is it right? Minus 4ac. So you need to multiply 4 with a with c. Is it clear everybody? Can I rewrite can I write in an elaborated manner? Yeah. See, I will give you, just look at this. Our value of a, b and c I have, and I will find the roots. Look at this. This space I will use. I am going to find the roots, and those roots is equals to, as per my formula, minus b. So minus of b is minus 5 plus or minus square root of b square. Since b is minus 5, b square is minus 5 square. Minus 4 times a is 1 and c is 6 and the whole thing divided by 2 times of a, which is 2 into 1. And now if you simplify, minus of minus 5 is 5 plus or minus square root of this minus 5 square is 25 and this 4 into 6 is 24 divided by 2. And this is equals to 5 plus or minus this square root of 25 minus 24 is 1, right? And root 1 is again 1 divided by 2. And from there we have two options, with plus sign 5 plus 1 by 2, with minus sign 5 minus 1 by 2. This 5 plus 1 by 2 is 3, 5 minus 1 by 2 is 2. At the end, this equation x square minus 5x plus 6 is equals to 0 has two roots, 2 and 3. That's the way to find the roots using formula method, right? We find the roots for this using factorization method as well as using perfect square method and using formula method again, right? Have a look at this. So at the end, see the formula for the ax square plus bx plus c is equals to 0. For the roots of that equation, minus b plus or minus root of b square minus 4ac by 2a is prepared by the perfect square method, is given by the perfect square method. Who developed this formula? Our idea of perfect square method develops the formula for the roots of the equation. Have a look at this. See, a simple problem related to the roots. Look at this. I have a problem, and for this problem, alpha and beta are the roots of this equation. As we discussed, this 2x square plus 7x plus 8 is equals to 0 is a quadratic equation. Surely it has two roots, and in particular here in the problem they mentioned there is alpha and beta. And since alpha and beta are the roots of that, they are asking us to find these values, right? So they may ask you the values in terms of beta also, right? For suppose if you change the question like 2 beta cube, 3 beta square, 15 beta plus 19, the values won't change because alpha and beta are the roots, right? So how to find those? Yeah, for that we need to utilize the basic idea for the root of an equation. Okay, so for this equation, alpha and beta are the roots. Okay, then as per the definition of the root is the value of x which satisfies the given equation. If you replace, which satisfies the given equation, that in the sense if you replace that root in the place of x, surely it balances the equation both left hand side and the right hand side. And in another way, if alpha is a root, that means at x is equals to alpha, the value of this expression is 0. That in the sense, since alpha is a root, if you replace alpha in the place of x, you will get that 2 alpha square plus 7 alpha plus 8 is equals to 0. Surely root will satisfy the given equation. And since beta is also a root, we have this particular thing also, like 2 beta square plus 7 beta is equals to 0. As per the definition of the root, we have these two relations. And now using those two relations, we need to find out the required values. When you look at the first thing, okay, I will solve the first and I will move for the second. When you think about the first one, they are asking you to find 2 alpha square plus 7 alpha plus 18. A simple thing actually. You may face different problems related to this. Yeah, 2 alpha square plus 7 alpha plus 18 you need to find. Right? We don't know alpha. No need to find the value of alpha using factorization method or using formula method or using perfect square method. No need to find, right? Okay. So don't find the roots, but just by using the definition of the root, you just try to find the value of this 2 alpha square plus 7 alpha plus 18. Yeah. Now you just rewrite it like this: 2 alpha square plus 7 alpha plus 8 plus 10. Is it right? This just I rewrite this 18 as 8 plus 10. Now, as per the definition of the root, this value is 0 plus 10 and that is equals to 10. At the end, the value of this 2 alpha square plus 7 alpha plus 18 is 10. Have a look at this. Is there anything wrong? Nothing, right? Look at this once again. So, this is purely by the definition of the root of an equation. Okay? No need to find the roots. You just move with the, what it is? The definition of the root. And afterwards you just try to solve the second one, which I gave you in terms of the beta. Some of you will try to find this value by finding the values of alpha. See, finding values of alpha and then finding this value is somewhat typical. Okay. For suppose if they may ask you like this. See, for this equation, alpha and beta are the roots, and now my question is, what is the value of 2 alpha square plus 7 alpha plus 18 to the power 10? Okay, see, if you finding alpha and then replacing the value of alpha here will took much of your time. Okay, and now as per this procedure, since this 2 alpha square plus 7 alpha plus 18 is 10, then directly your answer for this is 10 power 10. There ends your task. Is it clear? And now look at the second one. See, now you need to utilize the second relation. The problems looks like a logical thing actually. Okay. See, if you don't know about the basic definition of the root, you may feel somewhat difficult to find these type of problems. Okay. Now look at this. 2 beta cube plus 9 beta square plus 15 beta plus 19 value you need to find. Look at this. We have a relation on beta like this, where beta square is involved. But now the question is about the thing where beta cube is there. For that, you just multiply. This is an equation, okay? So, but the equation is in terms of beta. We need here beta cube. So, you just multiply every term of this with beta. If you multiply every term with beta, nothing wrong there, because the equation will get balanced if you multiply both sides. So, multiply here. 2 beta square into beta is 2 beta cube, plus 7 beta into beta is 7 beta square, plus 8 into beta, 8 beta, is equals to 0 into beta is 0. Look here. So 2 beta cube plus 7 beta square plus 8 beta is equals to 0. Now I need to find this value. But see here, it is 2 beta cube, 9 beta square, 15 beta. But this value is 0. So you just try to make this group from the given thing. So okay. Now here I am just rewriting 2 beta cube plus 7 beta square plus 8 beta in one group, plus actually there is 9 beta square. I utilized 7 beta square in this group and the remaining value is 2 beta square. And actually it is 15 beta. I utilized 8 beta here, still I have 7 beta, just use here. Okay. And now the constant value is 19. I am just separating the value as 8 plus 11, just like as above case. Look at this. Now this given 2 beta cube plus 9 beta square plus 15 beta plus 19 can be divided into 3 groups like this. Yeah, see, this first group value is 0, this second group value is also 0, whereas the third value 11 you left with, and that 11 is your answer. Right? Is it clear? I think exactly clear, right? A very basic definition related to that. Once again, look at this. I will. You may face different problems related to this, involving both alpha and beta at a time again. Okay? I will discuss everything in some other problems. Look at this. Yeah, this is the simple problem related to the basic definition of the root of an equation, right? Already we found the roots, and now the next task is, after having the roots for an equation, next task related to the problem's point of view, you need to learn about the sum of the roots and the product of the roots. Okay, I will just mention that, and I will give you a problem related to the sum of the roots and product of the roots. In the next session, I will start with that problem. Okay, right? And just look at this. Yeah, ax square plus bx plus c is equals to 0 is a quadratic equation, and we know that it has two roots. Let them as alpha and beta. Since the roots of the quadratic equation as alpha and beta, and as we find alpha is minus b plus root of b square minus 4ac by 2a, whereas beta is equals to minus b minus root of b square minus 4ac by 2a. Now look at the values of alpha and beta. Then from those values of alpha and beta, my next task is finding alpha plus beta as well as alpha into beta and alpha minus beta. These three values I need to find from this alpha and beta. Look, it is very simple. If you add alpha and beta, yeah, look here. See, I will add it. I will add just with an explanation. See, we need to add these two. The denominators are same, so that's enough to add the numerators. And while adding the numerators, this plus square root value and minus square root value gets cancelled. Then you left with minus b and minus b here, right? Do you wish to look here? Yeah. Then alpha and beta we are adding, okay? The denominators are them. The numerator is alpha minus b plus root d by 2a, and this is minus b minus root d by 2a. As we let that root of b square minus 4ac as 2a, write it here again like this, minus b minus root d by 2a. Okay, divided by 2a. Since we are adding, since the bases are same, directly you can write it like this. So here root d and root d will get cancelled. Then minus b and minus b is what? Minus 2b. So that is equals to minus 2b by 2a. These 2 and the 2 will get cancelled. At the end, the sum of the roots is given by minus b by a. alpha plus beta is equals to minus b by a, and that minus b by a is just nothing but sum of roots. Okay? And whereas next thing we need to find, that is alpha into beta, the product of these two. So while multiplying these two, what will happen? Just look at this. While multiplying these two, in the numerator again you have that minus b plus root d into minus b minus root d divided by 2a into 2a 4a square. Just multiplication. Yeah, I multiplied these two denominators as 4a square, numerators like this. Now just pay your attention on the numerators. These are of the form x plus y into x minus y. Then I may write it like this: minus b square, yeah, minus root d square divided by 4a square. We need to simplify it actually. Okay, I can write it like in a direct manner. Just look at this. This minus b square is b square minus root d square is d. Is it clear? But what is d? B square minus 4ac divided by 4a. This plus b square minus b square get cancelled. Minus of minus is plus 4ac, and the denominator we have 4a. Again that 4a will get cancelled. You left with what? C by a. So alpha into beta is c by a, and we will write it like a product of roots. Along with the sum of the roots and product of the roots, you need to know about the difference of the roots also. See, just I added here. In similar manner, if you multiply, for addition, root d gets cancelled, and whereas for subtraction, this b term will get cancelled, and you just have that root d with you. Is it clear? Yeah. Then if you add, you will get your answer as root d divided by a, and this is equals to difference of roots. If you wish, try to subtract. Okay. At the end, you need to memorize this sum of the roots as minus b by a, product of the roots as c by a, and the difference of the roots as root d divided by a. Have a look, and then if you need, go with the screenshot.